Welcome to the DIY Honda Garage channel. The presented issue pertains to the DTC codes P0136-17 and P0138, which relate to the secondary heated oxygen sensor, secondary HO2S or sensor 2. These codes indicate a detected high voltage in the secondary HO2S circuit. The vehicle's powertrain control module, PCM, monitors the output voltage of the secondary HO2S, and if this voltage exceeds specified limits, the PCM triggers these DTC codes. The secondary HO2S plays a crucial role in monitoring exhaust gas composition to ensure efficient combustion and reduce emissions. It is located in the exhaust system, typically following the catalytic converter, and works alongside other sensors to provide vital data for engine management. When this sensor's output is outside the expected range, it suggests an issue in the sensor itself, the wiring, or the PCM calibration. In the context of DTC codes P0136-17 and P0138, the error indicates that the output voltage from the secondary heated oxygen sensor, or sensor 2, has been detected at a higher than acceptable level. This high voltage output often indicates either a fault within the sensor itself or an associated electrical issue, such as a short circuit in the wiring or a malfunction within the powertrain control module, which processes sensor data and controls engine functions. The secondary HO2S is located downstream from the catalytic converter in the exhaust system of the Honda CR-V. Its role is essential as it helps to monitor the efficiency of the catalytic converter and the overall combustion process. In cases where this sensor outputs abnormal voltage levels, correction is vital as it directly impacts vehicle emissions and overall performance. There are several potential causes of the DTC codes P0136-17 and P0138, which should be methodically investigated. Firstly, a faulty secondary heated oxygen sensor could be the root cause due to its role as a monitoring device in exhaust emissions control. Secondly, issues such as open circuits or short circuits within the electrical connections or wiring associated with the sensor might lead to high voltage readings. Lastly, a malfunction within the powertrain control module, PCM, which processes signals from the sensor, should not be overlooked. If the PCM is not functioning correctly, it may misinterpret normal values as abnormal, triggering DTCs. Each of these possible causes must be evaluated to accurately troubleshoot and resolve the issue effectively. Symptoms associated with DTC P0136-17 and P0138 often manifest through several observable changes in vehicle performance. The most immediate symptom is the illumination of the check engine light, indicating a fault detected by the vehicle's engine control unit, ECU. Additionally, drivers may notice a decline in fuel economy due to inefficient combustion caused by improper sensor readings. This inefficiency can also lead to increased emissions, which not only impacts the environment, but could also result in failing an emissions test. Other possible symptoms could include rough idling or performance issues, suggesting real-time problems with the air-fuel mixture being managed by the PCM. Addressing these symptoms promptly can mitigate further complications in engine function. The first troubleshooting step for diagnosing DTC P0136-17 begins with starting the engine and allowing it to reach a stable operating condition. Once started, maintain the engine speed at 3,000 RPM with the transmission in either park or neutral. This elevated engine speed helps replicate conditions in which the secondary HO2S operates under load, allowing for accurate measurements of sensor output. After maintaining this speed, allow the engine to idle to observe any fluctuations or abnormalities in the exhaust readings. During this process, it is essential to monitor the performance of the radiator fan, which should activate due to the increased engine temperature. Successfully completing this step will provide valuable baseline data for subsequent diagnostic steps. In the second step of troubleshooting for DTC P0136-17, attention shifts towards inspecting the external circuits linked to the secondary HO2S. It's imperative to check the wiring associated with the SO2 signal and SO2SG signal ground circuits for any signs of wear, damage, or disconnection. To conduct a thorough inspection, ensure the secondary HO2S connector, 4P, is disconnected, as well as the PCM connector B101P. This step is crucial for confirming that there are solid connections and no breaks or shorts in the wiring. Additionally, the integrity of the signal path needs to be verified to ensure the PCM is receiving accurate information from the sensor. After all necessary checks, any abnormalities should be recorded for further analysis. Step 3 involves a detailed inspection of the powertrain control module, PCM, after any external circuit problems have been ruled out. This inspection is essential because the PCM could be malfunctioning, potentially leading to erroneous diagnostic trouble codes. The procedure starts with disconnecting the secondary HO2S connector, 4P, and utilizing a jumper wire to connect terminals number 1 and number 2, ensuring that the vehicle's ignition is set to on. The next step is to confirm the HO2S S2 signal via the HDS Honda Diagnostic System. A healthy reading should indicate an output voltage of less than 3.28 volts. If the voltage reading exceeds this threshold, it suggests that the PCM itself may have an internal fault, necessitating further repairs or replacement. In the final step of troubleshooting for DTC P0136-17, if all previous inspections have yielded normal results, focus shifts to the secondary heated oxygen sensor itself. This inspection will determine if the sensor is indeed the root cause of the issue. It is vital to confirm that the sensor's readings correlate with expected operational parameters. Given that it plays a critical role in monitoring exhaust gases and regulating the air-fuel ratio, any inconsistencies in performance may indicate that the sensor is malfunctioning. Depending on the findings, if the secondary HO2S is found to be faulty, it must be replaced to rectify the situation and restore the vehicle's performance efficiency. After conducting thorough inspections and potentially replacing the faulty components related to DTC P0136-17, the next stage involves final repair verification. Start by clearing the diagnostic trouble codes from the PCM. This is an essential procedure as it resets the system so that it can correctly monitor for any issues moving forward. Following this, it's recommended to conduct a test drive to allow the vehicle to reach operating conditions, simulating various driving scenarios to ensure that everything functions correctly. During the test drive, keep an eye on the dashboard for any illumination of the check engine light that may indicate a reoccurrence of the DTC. Post-testing, the system should be scanned again for DTCs to confirm that the issue has been successfully resolved, ensuring optimal vehicle performance. Preventive maintenance is crucial to ensure that issues related to DTC P0136-17 do not recur. Routine inspections of the vehicle's wiring and connectors related to the secondary heated oxygen sensor can help identify wear and tear before they lead to significant problems. It is advisable to check the functionality of the secondary HO2S periodically, ensuring it provides accurate readings. Furthermore, keeping the PCM updated with the latest software or firmware is important for the optimal functioning of the engine management system. This proactive approach not only enhances vehicle reliability, but also helps maintain compliance with emissions regulations, ensuring environmental standards are upheld effectively. In concluding the troubleshooting process for DTC P0136-17 and P0138, key takeaways include the importance of monitoring the performance of the secondary heated oxygen sensor, which plays an integral role in emission control and engine performance. Consistent inspections of wiring and connectors are vital to prevent any electrical issues that can lead to erroneous readings or faults. Additionally, maintaining updated software for the powertrain control module ensures that the vehicle's engine management system operates efficiently. By following systematic troubleshooting steps, from initial inspections to final validation, drivers and technicians can effectively resolve DTC-related issues, enhancing the longevity and reliability of the Honda CR-V. Please like and subscribe to the channel. See you next time.